In this video, we are going to look at a numerical on design of a slab. A problem in this can be worth 14 marks for you in the final exam. So let's read it. A simply supported one-way slab of clear span 3 meter is supported on masonry walls of 350 thick. Slab is used for residential loads. Design the slab. The materials are M20 and 415 and live load is 2 and use overall depth is 130 mm. Now, couple of things here. First of all, understand that is residential loads. Therefore, live load is 2. We can refer IS 875 and get the loads for different usage, but here we'll prefer to give you the load. Again, depth of the slab, there are a number of ways of assuming it, which we'll do it in a lecture. But just now you are being given as 130 mm overall depth, and what you are basically required to do is find the steel and give all the checks. So first is load calculation and effective span. So if 130 mm overall depth, dead load is 0.13 into 25, floor finish you usually take as 1 and live load is given as 2. So total is 6.25, and because we are dealing with limit state method, we multiply by 1.5. So the load per square meter, that is W, will be using as 9.4 kilonewton per square, kilonewton per meter square. Now effective span, if you remember the clauses, is clear span plus thickness of support, that is center to center support, that is 3350, or clear span plus effective depth, which in this case will come out to 110 because overall depth is 130. So we'll use it as 3.11 as effective depth. Now for flexures, you always consider 1 meter strip and design like a beam. This slab is nothing but 1 meter wide beam. So you get WS square by 8 and you get WS square by 2. We are basing it on clear span. Then effective depth required, from mu equal to QVD square you calculate. It is only 64, but actually you are provided 110. So you are okay. You are very much into singly reinforced range. If it was not so, then you would have to increase the thickness of the slab, because doubly reinforced slabs we don't do. Now regular method, you find mu by BD square, find PT, find AST, and then you choose. Now there you see in beam used to be number of bars. Here what is more popular is you give the spacing. So if you provide 8 mm tor at 150 center to center, you get 335, which is slightly higher than 309, and we have chosen that spacing. Now check for shear. As I said, no shear reinforcement. So just find out the shear stress at support. Okay, how? So for this unit PT, you get into Taussig formula, and you get it as 0.28. And you see it is for 150 mm thick slab, less than 150 mm thick slab, use K as 1.3. So here design shear strength of the slab is 0.364. Actual shear stress, if you work out, it will be only 0.12. That's all you have to do. You have to just show that it is safe in shear. Then check for development length, exactly in the same manner. Now, though there are various methods, I recommend L0 as 100 always. Find mu1 like we did in beams, and find Vu and find this. Now 1.3 comes because for simply supported, even for beams, you can use this formula instead of, you can multiply it by 1.3. Now work this out, and you find that 150, 15.4 mm is greater than 8, and that's how you have to show the development check is satisfied. Then you go for deflection, span to depth ratio, you need 20. Now here you will need that modification factor, you see, because here span to depth ratio will be more than 20. So therefore you get into the chart, which is on next page. You get modification factor 1.62, and you will get it as you will get, you see this is a modification factor chart, and then you will find that the deflection check is achieved properly. Check for cracking, simple. Maximum spacing permitted is 3 into 100, but you have provided 300, you have provided 150, so you are okay. And for distribution also suggest that you provide 150 and cracking is done. Now design sketch like this is a must. You can do either one. In the upper one you are bending the bar, in the lower one you are putting, even if it is not required, some 50% steel at the support. But this sketch I just said is a must, and you have to call this out, call this as a bar. This is a general sketch with distribution steel. So how much it is, main steel, how much it is, span, how much it is, all that you have to mention properly. So it's much easier than a complete beam design. Thank you.